Hello. I'll try to solve this question, one of the questions from non-concurrent forces, question 2.4. A couple of you got the questions wrong in the quizzes, so therefore I decided to solve it for you guys. So the question reads, determine the algebraic sum of the moments of all the forces shown about point A. So we have about 12 kilonewtons away 2 meters. 3 meters from that we have a force about 10 kilonewtons, which we need to find the direction, and another 10 kilonewtons which we need to find the components of it, the x and y, and the 5 kilonewtons which is away of 2 meters. So when you get these kind of questions, you really need to simplify the angles for you and then try to work around the 90 degrees and how can you simplify them, because it's very difficult to know the perpendicular distance from here to A. It requires a lot of trigonometry understanding. So I'll start first working on this force. So I'm just making a disconnected line to show the direction of this force. So what we know, this is 60, this is 90. So 60 plus 90 is equal 150 minus 180, so this force will be 30 degrees. I will just write it down to make sure that I will not forget that, because I need this force later. So 30, and go insert, insert and degrees. So that's angle here represent 30 degrees. Now since this force, I can transfer it to go in that direction, so it's be clear for me which direction it's going and the continuous action line for it. So if that's the force is 30 in that way, therefore by replacement this force is also Control C, Control V, I'm copying it here, this will be also 30 and 30, and the remaining of that will be 60. Now what we have? We have a components analysis for the force. So the first one is moving in that direction, which we call it, now we write the equation of it. I will not write this one for one reason, because if you see, the line action of this force will pass through the point A. Now because the question is clearly asking us to find it about point A, so definitely I don't need to bother myself about this force. But if it was about that point, yes, I need to find the components of this one. Therefore I'll move to the second one, which is the vertical components for this force. So technically it's around this point, and this one, as we learned, all right, the equation of this will be 10 kilonewtons, so 10 sine, and the angle is 30, because as we say, if we're going away from the angle, so it will be sine, and then we use the degrees to make sure when we solve this equation in degrees. So that's the first one we determine and we solve. Now the second part of it, it's how can we apply the analysis for the other 10 kilonewtons here, which I need to show you. Since this one is 60, now again, the easy way for us is just to sketch the components of this force. So we will have something around that point, it's going in that direction. Let's use the green color, and the other components of this force will be going upwards in that direction. Let's use again green color. So now if this is all 90, but look carefully to this diagram, this will be 60, by exchange this will be 60, therefore the remaining from 60, and so 90 minus 60, the remaining of that is 30 degrees. So since I have it here, I will just put that. So if this is 30, this should be 60 degrees, so 30 plus 60 will give you that 90 degrees. Now I'll write the components for that, since I have already here done it for that, so it's the same. So here will be 10 sine 30 degrees, because we're going away from the angle, and the other one will be 10 cosine 30 degrees. So if that's 10 kilonewtons will be cosine 30, and far away from it 10 sine 30. So after we done that, we found all the analysis for it. Now there is one thing we need to determine, is the direction of that. So this vertical 10 sine 30 degrees, it's away from that point to that point, so that's the action of that force. Therefore it's very difficult to do it here. I'll try to sketch something on the side. So I'll project whatever I have done on this side. So let's say this is my projection, and at some point this is my from here it's my 3 meters. Let's put it down. Let's enter the value 3 meters. So this is technically my 3 meters. So what I'm trying to do is just bring this 3 meters, and if this is 3 meters, Control C, Control V, this distance is equal to 2 meters. I'll bring it here. And now, so to be more clear, the point I'm trying to find is A. So replace this by A. So that's A. Here is 3 meters. Here is 2 meters. Now, the action force for 10 sine 30, it's passing through that point. So it's about that direction. So that's the green force, which has the value 10 sine 30. So I'll put here 10 sine 30. Now, to continue, what we were trying to achieve here is just we finished the triangular, and I'll show you more information about it. So let's say this is the triangular. So that's one. The angle we have in that angle is 60. So I'm just using the numbers which we have. So this is 60. And just let's try to close it. Okay. So this is 60. Now what else we have? We have that's 2 meters. So this distance to that point is equal to 2 meters. I'll copy that, Control C, Control V. This is about 2 meters. So now 60 is the angle, 2 meters. I need to find X. So which one is X? Control C, Control V. I'll use this X, the small tiny one. This is X. So just not confuse you with that scale. So I will put this one down, and let's put this so you can understand what we're doing. So this is X, the tiny one. Now the distance of 10 sine theta will be that distance only. Therefore, I need to find X value, subtract it from 3, and add that plus 2. So how can I find X? Very easy. To find X, we just write an equation for that. What we learned, so this is, please pay attention for it. So what do we have? Tan 60, you have the opposite divided by X. So we write tan 60 degrees. So I will use the degrees, equals to what? Equals to 2 divided by X. 2 divided by X. Rearranging this equation, definitely you will determine the value for X. X equals to 1.15 meters. Just rearrange the equation. So now, since we found X, we need to determine that distance, and we can add it. So what we say, 3 minus 1.15 will be equal to 1.84 meters. Represent for me. So I will show you where is this on the graph, so at least you understand what we're doing. So by doing this process, I determine this distance, which is 1.84 meters. Now, for that force will be 2 plus 1.84. Now you say, which 2? We're taking this 2 plus the 1.84 will give me the total distance of 3.84 meters. So that's what we're trying to achieve. So this is kind of the action line for the 10 sine 30 degrees towards the point A. Now, since we found all the dimension, I'll go through it one by one and show you how it works. So we start again here, a new line for our equations. What we do, we say insert equation. Since we're writing algebraic summation, so large operators, I will choose this one, and then I will use for example, a moment around point A. Why? Because the question wants us to find algebraic sum of all the moments, or of all the moments of all the forces shown about point A. This will be equal to 0. Now what I have done, because I want to solve it using this method, so it's kind of counterclockwise. This will help me to distinguish in the direction of the forces. So let's start solving this step by step, and we'll see force by force how it works. Okay, clockwise is the positive direction for me. Look at this sign, I made it clear here, so you need to follow it now. So the first one, we start with the 10 sine 30. So write 10 sine 30 degrees. So that's itself, it's only the force. I haven't added the distance yet. So 10 sine 30. Now open brackets. I don't want it to confuse you guys with writing, times the distance between this action line to A, which is 3 plus 2. So I'll write 2 plus 3 to make sure you guys see it later. Plus. Now, I can't take this into consideration, this force, because it's actually passing through point A. Therefore, I move to the other one. The other one is 10 cosine 30. And if you see, this will rotate. If I hold this point at point A, this will rotate in that direction. So it will be, this force will be 10 cosine 30 degrees, or other degrees, times the distance from here to there is 2 meters. So distance from 10 cosine to here to there is 2 meters. Also, plus what we have, 10 sine 30 degrees. Now I'm moving to this force, 10 sine 30 degrees, and I'll use as well the degrees times the distance. Which distance? The one we found here, 3.84. So that's distance we found earlier, 3.84. Alright, now we finished these forces, which we took us a bit of time to find. Now we move to the other force. So the second one is, let's move to this. 12 would take you as well to rotate clockwise, so plus 12 times the distance, 2 meters. Now, see, for the 12 we didn't worry because it's already the line of action is perpendicular, so there's no problems. Now, the other force is 5 kilonewtons. 5 kilonewtons will rotate in that direction, therefore is not with the same direction as you, is negative. So it will be minus 5 times the distance from here to point A is 2, and then I'll close that. We solve that. After you're adding all the equations and solutions, you find the final answer is equal 37.5. It's possibly could be rounding numbers. Depends on the calculator using for the answer. So this is technically the final answer for your questions. I will say that it took us a bit of time to do the components analysis for the forces. So what I did here, kind of, I revised what we have done through concurrent forces here, concurrent forces there, and then we used the non-concurrent forces to take the moment about A. This is really very important. I use a bit of mathematics trigonometry techniques. So the distance we are interested to find, so that distance, if I highlight it for you guys, it's actually, it should be from here to point A. That's the perpendicular. So if I extend that line to show you, and then I put this here, that's the action of the line which took us to find the value 3.84. So that's where we were focusing to determine 3.84, and that was very important. So we could multiply the 10 sine 30 degrees times the 3.84. This is kind of, you can work it out very fast by your experience, and it's up to you. So it's a very good question. It shows you a lot of techniques you need to use. It tests your capabilities in mathematics and how can you apply the moments. I hope you enjoyed the video, and you can see me in class if you have another questions. Good luck. See you in another video or in class.